Welcome to The Explainer. Today, we're jumping into the massive and, let's be honest, sometimes really confusing world of machine learning tools. If you've ever looked at all the different languages, frameworks, and platforms out there and just felt overwhelmed, then you are definitely in the right place. We're going to break it all down. So we're going to tackle this by thinking like a master builder who's putting together the perfect toolkit. See, building an AI model isn't about searching for one single magical tool that does everything. Nope. It's about knowing which tools to pick and combine for the specific job you have in front of you. So let's ask the big question. What should be in your toolbox? But hang on, before we even think about picking up a tool, we need a blueprint. And in the world of AI, that blueprint is all about understanding the core challenge of any project, how you're going to train and evaluate your model. This is that critical first step where an idea starts to become a real intelligent system. And right away, you hit the fundamental trade-off in machine learning. On one side, you have your simpler models, things like decision trees or support vector machines, SVMs for short. They're quick, they're efficient, they don't need a ton of data. But on the other side, you've got these complex deep learning models that demand huge amounts of computing power and data, but they can pull off some pretty incredible things. The real art is matching the power of your tool to the complexity of your problem. So why do we go through all this trouble with training? It's all for this one thing, generalization performance. You've got to remember this term because it's the single most important metric. It doesn't really matter how great your model is on the data it's already seen. What truly matters is how well it works in the real world, on new data it has never, ever encountered before. That is the goal we are always chasing. All right, we've got our blueprint. We know what we're aiming for. Now it's time to choose our foundation. Your programming language is the raw material, the bedrock you're going to use to build everything else. So let's check out the main options. Okay, so here are the main players on the field. You've got Python, which is kind of the versatile all-rounder. Then there's R, the specialist tool for statisticians. You've got Julia, the absolute speed demon, and Scala, the industrial strength engine built for massive jobs. As you can see, each one has its own personality and purpose. I love this quote because it just perfectly sums up Python's power. It might not be the #1 absolute best at any single thing, but its incredible flexibility and the fact that it's pretty good at everything makes it the king of data science. It was popularized by Google, it's easy for beginners to pick up, and it has this massive ecosystem of libraries like NumPy, Pandas, and scikit-learn that do a ton of the heavy lifting for you. R, on the other hand, is like a precision instrument. It was designed by statisticians for statisticians. Its real superpower is in deep statistical analysis and creating absolutely incredible data visualizations. Plus, it has something called the CRAN repository. That's the Comprehensive R Archive Network, which is basically a goldmine of prepackaged, cutting-edge statistical techniques ready to go. But what if you just need raw, unadulterated speed? Well, then you need to meet Julia. This is a language that was built from the ground up for one thing, high-performance computing. And here's a little proof. The Federal Reserve Bank of New York used it to model the entire U.S. economy. The result? It was 10 times faster than what they were using before. When speed is everything, Julia is a serious contender. And then there's Scala. Think heavy industry. Think power. Scala runs on the Java Virtual Machine, or JVM, which means it can plug right into Java's gigantic ecosystem of tools and libraries. Its real claim to fame in data science is its connection to Apache Spark, which is the framework for big data. And Spark itself is written in Scala. Okay, so our foundation is chosen. Now it's time to stock our toolbox with some real power tools. These are the frameworks that automate the hard stuff, letting us build really sophisticated models without having to reinvent the wheel every single time. And here are the big ones. Scikit-learn is like your versatile, trusty Swiss Army knife for all-purpose machine learning. But for the really heavy lifting, for deep learning, you're looking at Google's TensorFlow and Meta's PyTorch. They're the go-to for building complex neural networks. And Keras, it sits right on top of TensorFlow, giving you a much simpler, user-friendly way to get started. Now, we have to pause and give Apache Spark its own moment, because this thing is just in a league of its own. It is, without a doubt, the undisputed king of big data processing. When you have truly massive data sets, Spark is the tool that makes crunching all that information not just possible, but fast. It's pretty much essential for any serious enterprise-level AI project. Every builder needs a workbench, right? A place where you can lay out all your parts, you can tinker, you can experiment, and you can watch your creation come to life. In data science, that workbench is the interactive notebook. You see, the magic of a notebook is that it's not just for writing code. It's more like a living document. You can combine your live, runnable code, the charts and graphs it generates, and all your notes explaining what you're doing, all in one place. This makes your work super easy to share and reproduce, which, is the foundation of good science. The two biggest names you'll hear are Jupyter and Colab. Jupyter is the original, the open source standard that really started this whole revolution. But then Google took that idea and put it in the cloud with Colab, and they added a complete game changer: free access to powerful hardware like GPUs. Those are graphics processing units. For deep learning, that's huge, because GPUs can slash your training time from days to just hours. Great builders almost never work completely alone. They're part of a community where they can learn from others, share their own tricks, and get pushed to be better. In the world of AI and machine learning, that global town square is Kaggle. Just take a second to look at that number. Over 8 million users. We're not talking about some small niche forum here. This is a massive, thriving digital city of data scientists. For anyone just starting out, that means there are millions of projects to learn from and a whole planet of experts to connect with. Kaggle's own story really mirrors the evolution of the entire field. It started out back in 2010 as a straightforward platform for hosting machine learning competitions. But then Google bought it in 2017, and it blew up into this comprehensive platform with datasets, training, and now even shareable pre-trained models. It's become a genuine one-stop shop for getting your hands dirty with AI. And all of this brings us to a really critical question. We've just walked through this incredible variety of languages, frameworks, and specific needs, from tiny models all the way up to huge planet-scale systems. So, with all that complexity, how on earth could there possibly be a single one-size-fits-all platform that's perfect for everyone? And that right there is the answer. The goal was never to find one perfect tool. The goal is to become a master builder, someone who knows how to look at a job, understand its unique challenges, and then assemble the perfect toolbox for that specific project. The real skill isn't mastering one platform, it's understanding the entire ecosystem so you can pick, choose, and combine the right tools for the job. That's how you build the future.